This is the 4B11 D4 Myvec engine, now used in the 2008 Lancer. Now, as I said before, it's an all-aluminum cylinder block and head engine with variable valve timing for both intake and exhaust. This engine comes as a 152 horsepower federal spec model or a 143 horsepower California spec model. The cylinder head is also aluminum alloy and designed for excellent cooling efficiency. This engine uses a plastic cylinder head cover for weight reduction. Also, if you'll look at the cams, you'll see that the intake and exhaust camshaft is supported by 5 bearings. Now, I'm going to remove the number 1 intake cam bearing cap to show you the number 1 bearing. I want to show you a couple of features relating to the camshaft. Now, you'll see that the load is supported by the number 1 bearing, and you'll also notice that the number 1 bearing for the intake and the exhaust share a common bearing cap. Also, you'll notice that all the other bearings are part of the head and not a separate insert. Now, if you're wondering about servicing the head, the factory service manual says that you may only surface the head once and no more than 0.2 millimeters. Otherwise, you'll have to replace it. Also, the guides and seats are replaceable.
There is additional information regarding the valve train that has become available after the production of this program. A new direct action valve train is now being used on the 4B11 engine. Valve lift is now being done directly by the camshaft. The valve clearance is adjusted using valve tappets. There are 47 different thickness tappets, and they are selected to ensure proper valve clearance. They ride atop the valve in the cylinder head with the camshaft lobes in direct contact. As the camshaft rotates, the lobes push the valve tappet, opening the valves. The clearance can be inspected using a thickness gauge. The procedure for this is in Group 00 of the service manual. There is also an inspection of tappet thickness, which is performed during overhaul. Valve clearance should be inspected at 60,000 mile intervals. Valve clearance will require adjustment if the valve or camshaft is replaced or if a valve job is performed. The complete inspection and adjustment procedure is in Service Manual Group 00.
The head gasket is a metal type gasket, and the cylinder head bolt is a 1 torque only bolt. This means that you only use this bolt once and then replace it. There's nothing big to know about the piston or rods, but the pins are press fit into the connecting rod, the pistons are select fit, and the cylinder block is stamped with an A, B, or C. Rod bearings are also select fit. The cylinder block is a 2-piece design. The lower portion of the block is known as the ladder frame. The main bearing caps are not part of the ladder frame. There are 5 of them, and the thrust load of the crankshaft is supported by the number 3 bearing. If you'll notice, here in the front of the engine, there's a small oil jet which is used to lubricate the timing chain. Since the block is aluminum alloy, there are steel sleeves or liners inserted into the block. These sleeves are not serviceable. Also, remember the main bearings are select fit bearings. There are 3 upper bearing sizes and 5 lower bearing sizes. Next, I'd like to spend a little time talking about the timing chain and show you the different timing marks for this engine and how to replace the chain should the need arise. Now, the 4B11 uses a timing chain instead of a timing belt. Tension is provided by a hydraulic tensioner and resin guides that you see here. So, let's remove the timing chain and replace it to familiarize yourself with the steps involved in that procedure. First, remove the upper chain guide. Then use a small screwdriver and insert it into the tensioner to release the latch. Collapse the tensioner all the way back and insert an Allen wrench into the plunger hole to hold the tensioner in place. Then go ahead and remove the timing chain tensioner. Then you'll want to remove the tensioner lever. Remove the chain guide and then the chain. Now, that was pretty basic, and I'm sure all of you watching this can get through that part with little to no problem. So, to install the chain, make sure that all the timing marks are aligned, and that's what I'm going to show you next. First, align the timing marks on the VVT sprocket. Look for these small marks on the sprocket and line them up with the edge or top of the cylinder head. Then, align the crankshaft sprocket key to the 9 o'clock position, the same as you see here. Once you have the two camshaft sprockets lined up and the crankshaft sprocket lined up, then go ahead and install the timing chain by aligning the link plate with the secondary timing mark on the exhaust cam and the intake cam. Place the timing chain painted link on one timing mark of the exhaust sprocket and the other painted timing chain link on the intake sprocket timing mark. Then install the chain over the crankshaft sprocket and align the timing mark on the crankshaft sprocket with the colored link on the chain. Now, take one last look and see that all the timing marks are lined up with the marks on the sprockets. Then, install the timing chain guide and tensioner lever. Next, install the tensioner. Now, once the tensioner is installed, remove the Allen wrench from the tensioner, and this enables the plunger of the timing chain tensioner to push the tensioner lever to keep the timing chain tight. Now, after you're finished, you can rotate the crankshaft clockwise 2 times to align the timing mark of the VVT sprocket with the top surface of the cylinder head. And there you have it. So I've shown you how to remove the timing chain and how to replace it correctly. Next, we're going to take a look at how the variable valve timing works. The 4B11 engine is equipped with a variable valve timing system that's very much like the one used on the Evo 4G63. However, this new system can also vary the timing of the exhaust valves as well as the intakes. Lift and duration are not changed. Now, as in the Evo, sprocket control is done by using oil pressure from the cylinder head to advance or retard the sprocket. So, let's step through this process in the Lancer one point at a time, so this will help you understand how the system operates. First of all, the name MyVec has changed a little because of the variable timing. On the 4B11, equipped with variable valve timing, MyVec stands for Mitsubishi Innovative Valve Timing Electronic Control. Now, the variable valve timing system allows the valve timing to be optimized corresponding to the running condition of the engine. That way, increased torque and output is obtained at any speed while increasing idle stability. In this system, you have 2 oil control valves, one for the exhaust cam and one for the intake cam. You also have an exhaust actuator and an intake actuator. In the actuator, valve timing is changed by rotating an internal vane rotor with oil pressure from the oil control valve. The crank angle sensor and the cam position sensors at the end of each camshaft inputs the signals to the ECM needed to determine the amount of advance or retard timing. During operation, the ECM receives inputs from the crankshaft sensor and the 2 camshaft sensors. It also receives engine load data to determine advance or retard. The ECM determines proper cam timing and signals the oil feeder control valve. The oil feeder control valve uses an electromagnet to move a spool valve, which in turn directs engine oil to the cam actuators. Oil from the oil gallery is directed through the oil control valve's spool valve through the camshaft to the actuator. If the ECM determines that the valve timing needs to be advanced, then oil is directed into the advanced chamber of the cam actuator. If the ECM determines that the valve timing needs to be retarded, then oil is directed into the retard chamber of the cam actuator. Oil pressure is constantly being applied independently to either the advance or retard chamber to change the phase of the intake or the exhaust camshaft during engine operation. The exhaust cam sprocket has a spring in the body. While the engine is stopped, the exhaust valve timing will be set to the maximum advanced position. The spring helps set the sprocket to that position. There's a unique balance between high torque, high output, and low fuel consumption. The valve timing is constantly changing to optimize these ranges to ultimately give the driver improved performance. So, as you can see, the operation of this system is pretty simple. If you understand the operation, well, then you shouldn't have any trouble identifying any problems that might come up. Now, there's just a few more items I want to go over before we leave the engine.